Good morning, ma'am. This is Monica from the department. My roll number is 234G10261. Today my topic is explain about lag compensator. Compensator, a device inserted into the system for the purpose of satisfying the specifications is called compensator. Here series compensation, parallel compensation or feedback compensation. Here we have three types: lag compensator, lead compensator, lagged compensator. Now you should want to tell about lag compensator. Explain about lag compensator. Lag compensator. A compensator having the characteristics of a lag network is called a lag compensator. If a sinusoidal signal is applied to a lag network, then in steady state the output will have a phase lag with respect to input. Lag compensation results in a large improvement in steady state performance but results in slower response due to reduced bandwidth. The attenuation due to the lag compensator will shift the gain crossover frequency to a lower frequency point where the phase margin is acceptable. Thus, the lag compensator will reduce the bandwidth of the system and will result in slower transient response. Lag compensator is essentially a low pass filter and so high frequency noise signals are eliminated. Explained representation of lag compensator. Here we want to know about the S-plane. How to show the S-plane means transfer function of lag compensator. GC of S equals to S plus ZC by S plus PC. Here we write ZC equals to 1 by T and PC equals to 1 by beta T. Now the formula is S plus 1 by T by S plus 1 by beta T. Here S-plane diagram is shown. In upper line plus j omega and down minus j omega. Here we shows the star indicates the minus 1 by beta T and here another star indicates the minus 1 by T. Realization of lag compensator using electrical network. In the network shown in figure, the input voltage epsilon I of S is applied to the series combination of R1, R2 and C. The output voltage epsilon naught S is obtained across series combination of R2 and C. Here is the diagram of the realization of lag compensator using electrical network. Here we consider the two resistance and one capacitance. Here one R1 and R2 and capacitance indicates the 1 by SC. Here we shows the epsilon naught of epsilon I of S in epsilon naught of S. Epsilon naught of S equals to epsilon naught of epsilon I of S R2 plus 1 by SC by R1 plus R2 plus 1 by SC. Epsilon naught of S equals to epsilon I of S into SC R2 plus 1 by SC by SC into R1 plus R2 plus 1 by SC. Here we cancel the SC. Epsilon naught of S equals to epsilon I of S SC R2 plus 1 by SC into R1 plus R2 plus 1. Epsilon naught of S by epsilon I of S equals to SC R2 plus 1 by SC into R1 plus R2 plus 1. In practical system, adjustment of gain alone will not be sufficient to meet the given specifications. In many cases, increasing the gain may result in poor stability or instability. In such cases, it is necessary to introduce additional devices or components in the system to alter the behavior and to meet the desired specifications. Such a reading or addition of a suitable device is called compensation. The compensator basically introduces pole and zero. Pole or slash or zero in open loop transfer function to modify the performance of system. The compensation schemes used for feedback control system either serial compensation and parallel compensation. Thank you, ma'am.